Good morning students. Today we are discussing toppers IIT-JEE NEET Foundation, the single correct answer type questions in the toppers 9th class light lesson. Question number 12. A wire mesh consists of squares of each side 1 mm. It is placed at a distance of 9 cm from the magnifying glass of focal length 10 cm. It is viewed by a placing eye close to the lens. What is the area of the each square in the virtual image of the mesh? So to find the area, first of all we should find the magnification. So the formula of magnification is, magnification is nothing but magnification is image distance by object distance. Image distance by object distance, that is the magnification. First of all, here object distance is given. A wire mesh consists of squares side 1 mm. It is placed at a distance of 9 centimeters. 9 centimeter is the object distance. 9 centimeter is the object distance. The focal length is 10 centimeters. The focal length is 10 centimeters. So V equal to, we should find out. The formula is 1 by F equal to 1 by V minus 1 by U. 1 by F equal to 1 by V minus, that is the lens formula. So here object distance is negative. On the left side of the lens it is going to be there, that's why minus 9 centimeters. 1 by 10 equal to 1 by V minus 1 by minus 9 centimeters. If you simplify this, 1 by V, 1 by V equal to minus into minus plus, 1 by 10 minus 1 by 9 will come. 1 by 10 minus 1 by 9 will come. So if you take LCM, so 90, so that becomes 10 9 ja, 9 10 ja. So minus 1 by 90 will come. That is V equal to minus 90. V equal to minus 90 centimeters. This is the V value. Then magnification from this you will get V by U minus 90 by minus 9. Magnification is nothing but minus 90 by minus 9. It is 10. So 10 is the magnification value. Magnification is 10. So by using this magnification you can find the area of the squares. Aerial magnification should be taken. Aerial magnification is nothing but, aerial magnification, it is nothing but V square by U square. So magnification you got 10, hence aerial magnification is nothing but, so you can take it as 10 square, that is nothing but 100. So now here the wire mesh consists of squares of each side 1 mm. Square, the area of the square, the object is here square. So area of the object if you take, area of image by area of object. This is the formula for aerial magnification, that equal to 100 here. So now area of object is, the side of the square is 1 mm, the area of the square becomes 1 mm square. So then area of the image is equal to, 1 mm square into 100, that becomes 100 mm square. This is the area of the image. The area of each square in the virtual image. So 100 mm square. So option B is the correct answer, 100 millimeter square. The remaining options if you take, this is 10 mm square wrong, 100 mm square wrong. So sorry, this is 1000 mm square. This is the correct answer. The correct answer is This one is the correct answer, 100 mm square, not 1000 mm square. Okay, so option C is the correct here. See, 120 is also wrong answer. So the right answer is 100 mm square. I hope it is clear. So the next question, the explanation for this, see, first you try to find out magnifying glass, the magnification is 10, area of each square is 1 mm square. Since the magnified is 10 times, 10 into 10, 100 mm square. See, that is the way, so you can get the answer for this question. See, next 13th question. A wire mesh consists of squares, each of side 1 mm. It is placed at 9 cm, magnifying focal length 10 cm. It is same question. It is viewed by placing the eye closer, magnifying power of the lens. See, magnifying power of the lens. It is just similar to that. Magnifying power should be find out. See, just now we calculated focal length and object distance, everything we calculated. So, magnifying power. See, magnifying power is nothing but, magnifying power is nothing but least distance by x. The x value is 9 centimeters. The least distance of vision is 25 centimeters. So 25 upon c, that is 25. Magnification is nothing but here. Yes. See, magnifying power is nothing but m equal to d by x. M equal to d by x. See, the d value, least distance vision. Least distance vision is 25, and the distance x is the numerical value of the distance of the object from the lens. That is object distance. Object distance is 9 centimeters. So object distance is 9 centimeters. 25 by 9. 25 by 9 is approximately, it is 2.8. See, in the given options, if you take, in the given options, 2.8. So 2.8 is the see 2.8, option B is the correct answer. See, the remaining 12.7, 4.6, 9.7 are the wrong answers for this question. So this is about question number 13. So solution is this. 14th one, a compound microscope. A compound microscope, you know, microscope which consists of eye lens and objective lens. There are two lenses are placed on the same line. So compound microscope, two lenses will be there. Object lens is closer to the object, eye lens is closer to the eye. So a compound microscope has magnification is 30, assuming that the final image is formed at a distance of least distance vision, that is 25 centimeters. Find the magnification produced by the objective. So given that the focal length of the eye lens is, given, it is 5 centimeters. See, you have to find out what is the question here? Find the magnification produced by the objective lens. See, the magnification produced by the objective lens, if you take, see here, if you observe carefully, the magnifying power is given. The magnifying power is given. See, this is the magnifying power. 30 centimeters. The focal length of the eye lens is, magnifying power is 30 centimeters. The focal length of eye lens is 5 centimeters and the least distance vision is 25 centimeters. This is the given data. So power equal to, magnifying power is equal to magnification of objective lens and magnification of eye lens. Magnification of objective lens and magnification of eye lens. So if you take that, the magnification of objective lens and magnification of eye lens. So magnifying power, it is given 30. So that equal to magnification of objective lens, you have to find out here. The magnification of objective lens. See, magnification of eye lens is 1 plus d by f. 1 plus d by f. This is the magnification of eye lens. Least distance of vision upon. Okay, so if you try to find out 30 equal to, so magnification of objective lens 1 plus, that is least distance vision is 25, focal length of eye lens is 5. So if you try to calculate 5 5 is 25, 5 plus 1 is 6. So magnification of objective lens is 30 by 6, it is 5. Magnification of, so that is 5. 5 is the magnification of objective lens. So if you observe the options are option A 2. So that is 2 is, see 2 is wrong answer. Similarly 3 is also wrong, 4, but option D 5 is the correct answer. So you can select like this. This is the question number 14. Next question, this is the 14th solution. Just now I explained magnification of objective lens and eye lens. So go to the next question. A simple microscope is made combination of two lenses. A simple microscope made combination of two lenses. One is, they are having a powers 15 diopters. So there is 15 diopters and 5 diopters, plus 15 plus 5 diopters. Calculate the magnifying power of the microscope. The image is formed at 0.25 meters. Then least distance vision is what? The least distance vision. If you observe, this is the simple microscope, consists of two powers are given. The two lenses are there, 15 plus 5. So the total power is equal to, the solution if you see, power of the first lens is 15 diopters. The power of the first lens is 15 diopters. See, power of first lens is 15 diopters. The power of second lens is 5 diopters. The total power is power of 1 plus power of 2. That is 15 plus 5. It is 20 diopters. 20 diopters. If you know the, see, if you know the power, then you can find the focal length. The focal length equal to the reciprocal of the, see, the reciprocal of the power. The power is reciprocal of focal length. That's why 1 by p equal to 1 by 20. So that becomes 0.05 meters. This is the focal length. See, 0.05 meters. If you observe here, this is the focal length. Once if you got the focal length, then magnification is nothing but 1 plus d by f. 1 plus d by f. If you try to find out the value, see, magnifying power of the microscope you have to find out. Magnifying power of the microscope is nothing but, so that is actually 1 plus d value is given 25 and focal length is 0.05. So if you take it as, so 25 centimeters in meters, it is 0.25. 0.25. So it is 0.25 upon 25. It is magnifying power is 6. The question is for magnifying power, not least distance vision. Least distance vision is 25. Okay, so 25 centimeters. So if you take the options here, see, the options are given here. See, the magnifying power, it is not supposed to be centimeters. Calculate the magnifying power. The centimeters supposed to be not there. 6 is the answer. The remaining options are, see, the remaining options if you take here, so 12, 15 centimeters not supposed to be there. Okay, so this is not there. So 6 is the correct answer. Okay, so magnifying power is 6. 6 is the correct answer for this question. So the next one is question. This is the simple explanation for the magnifying power. Then question number 16. A simple microscope of a convex lens, focal length is 10 centimeters, magnifying power. Same type of question. See, magnifying power should be find out. The magnifying power is here also, if you take that, magnifying power is equal to 1 plus d by f. 1 plus d by f. Here the focal length is 10. So it means 1 plus least distance is 25 upon 10. That is 25 upon 10 is, so 2.5 plus 1. That becomes 3.5. In the given options, option C is the correct answer. The remaining options are 4.5, 2.5 and 1.5 are the wrong answers. So that is 3.5. So for this solution, simple solution 3.5, 25 is the least distance. So this is the solution for this question. See, next 17th question. Find the magnifying power of a simple microscope of focal length 5 centimeters. Same type of question. Magnifying power. So magnifying power is equal to, if you take magnifying power, same formula, magnifying power is 1 plus d by f. 1 plus d by f. So 1 plus d value is how much it is? 25, least distance, 25 upon 5. So that becomes 6. In the given option, the 6 is the right answer. The remaining options are wrong. See, 2 is wrong and 4 is wrong, 8 is wrong. 6 is the correct answer for the question number 17. So the next question, if you see, this is the simple explanation. The focal length of the objective and the eyepiece of a microscope 4 mm and 25 mm respectively. Final image is formed at the infinity. The length of the tube is 16 centimeters. Length of the tube is given 16 centimeters in the compound microscope. What is the magnifying power of the microscope? See, when the image is formed at the infinity, the magnifying power is nothing but, so magnifying power, if you try to find out, so minus LD divided by F naught by F naught FE. See, the formula is, when image is formed at the infinity, so magnifying power is equal to minus LD by focal length of objective lens into focal length of eye lens. L is the length of the tube. The length of the tube is here minus 6, here 16 into the least distance vision is 25. Focal length of eye lens is given 0.4 and 2.5. See, that is 4 centimeters and 25 cm. See, that is given as, if you observe here 4 mm and 25 mm. If you convert into centimeters, so 4.5 and 25, 2.5. That's why it is taken like that. See, now if you simplify this, you will get minus 400. The magnifying power is, when image is formed at the infinity, magnifying power is here minus 400. Objective lens and eye lens in the compound microscope. Fy is nothing but focal length of objective lens. Fe is nothing but focal length of eye lens. You can find out like this. So thank you very much. Thank you for hearing this class. Thanks.